Hello, and thank you for coming by my poster. I'm going to give you a brief overview of what you can find in here, and if you have any more questions or want to learn more, please feel free to come by and check out the full poster in detail, or you can reach out to me later. For our project, we're looking at using wearable sensors. In recent years, the desire to improve clinical gait assessments has motivated the use of instruments to quantitatively analyze gait. Standard instruments, like a force plate, are costly and can only record data at a single location. However, wearable sensors can record data continuously and at a low cost. So our group has recently contributed by adding a novel wearable sensor made out of fabric. Our goal for this project is to validate this sensor for detecting ground reaction force during walking. In order to do this, we had subjects walk on a treadmill at various speeds and compared the measurements from a force plate to the measurements of our wearable sensors. Our methods involved first calibrating the individual sensors to estimate force, then conducting a secondary calibration to account for the unsensed midfoot region between the two sensors, then using cross-validation to evaluate the mean performance of our calibrated system, and using the Bland-Altman method in order to evaluate the differences in agreement between our two systems. When looking at the mean ground reaction force curves for the force plate and our calibrated wearable sensors, we see that the magnitude and shape of the curves are comparable at all three walking speeds that we tested. Furthermore, when we look at the Bland-Altman analysis, we conducted two assessments, one involving looking at the weight acceptance and push-off peaks, which we called the two-peak analysis, and one looking at just the absolute maximum from each gait cycle, and we call this the max. Now, when we look at the 95% limits of agreement for the system within which 95% of the differences between them will lie, we found that for the two-peak system, for the entire group, the differences lied between negative 0.27 and 0.25 body weights. On the other hand, for the max assessment, they're between negative 0.17 and 0.2 body weights. We also found that when we looked at individual subjects, the results tended to improve when subjects had larger foot areas. So overall, a study showed that there were comparable ground reaction force curves between the wearable sensor and force plate at all three speeds. We saw that the foot area influenced the agreement between the wearable sensor and the force plate. And we saw that our study actually outperformed prior studies by a little bit when looking at the mean of difference, which measures the bias in the systems, and two standard deviation values, which define the size of those limits of agreement. If you have any more questions about this study, please stop by my poster, or you can reach out to me. My name is Caleb Birch. My email is kbirch@udel.edu. Thanks.